Kimi K3 just dropped as a 2.8 trillion parameter reasoning model, and it's going straight at Gemini 3.6 Flash. One number tells you why this fight is real. Gemini already has a verified sub-V bench pro score of 58.7%, and Kimi K3 has 0 published numbers to match it. Both models launched recently, and developers are choosing right now, so the stakes are real money and real wait times. We're comparing Kimi K3 versus Gemini 3.6 Flash across 4 real tests: reasoning, pricing, latency, and code generation. Every number comes from verified sources, no vendor spin. The hard truth is the final score is not what you'd expect from a 2.8 trillion parameter model going up against a Flash tier product. One of these models wins on price, speed, and published proof, and the other wins on something very different. Who is this for? Developers and teams picking an API right now, because this comparison directly affects your bill and your users' wait time. Pick wrong and you're either paying double or waiting over 4 minutes for a first response. That's not abstract, that's real cost and real friction in your product. Test 1 multi-step reasoning. This matters most if you're running complex agent workflows or hard math problems, because a model that can't chain multiple steps reliably breaks every downstream task. We need to know which of these two actually handles deep reasoning and whether the numbers back that up. Gemini 3.6 Flash has a published SWE Bench Pro score of 58.7%, reported by press sources. Kimi K3 has no published figure on that same benchmark. Moonshot claims K3 beats Claude Opus 4.8 on coding tasks, but that's vendor reported only, with no third-party replication yet. You're looking at one-sided data. This test is a tie, too close to call. Crowning a winner when only one side has published numbers and the other runs on vendor claims alone is impossible. The score after test 1 sits at Kimi K3 0, Gemini 3.6 Flash 0, 1 tied. The gap here might be smaller than the missing numbers make it look. K3 uses a mixture of expert setup with 16 of 896 experts active and always on max, taking a genuinely different architecture from Gemini's Flash class approach. Once independent evals land for K3, this picture could flip pretty fast. Test 2 API pricing. At scale, even a small price gap per million tokens adds up to hundreds or thousands of dollars a month. Pricing is also where hidden costs tend to hide, so you want to look at the full picture, not just the headline rate. Gemini 3.6 Flash runs at $1.50 per million input tokens and $7.50 per million output tokens. Kimi K3 runs at $3 input and $15 output. That's exactly double on both sides. K3 has no non-thinking mode, so every call generates reasoning tokens billed at that full $15 output rate, which makes the real-world cost gap even wider. Gemini 3.6 Flash takes this test, and it's not close. Half the input price, half the output price, and no mandatory reasoning surcharge stacked on top. Score: Kimi K3 0, Gemini 3.6 Flash 1 tied. S3 response latency. Speed matters the second a real user is waiting on your app. If the restaurant is amazing but the wait is 4 hours, most people just go somewhere else. Latency is the thing that kills user experience even when the output quality is great. K3's measured time to first token is 252 seconds. That's over 4 minutes per artificial analysis, measuring a single provider. Gemini 3.6 Flash has no published TTFT number, so a direct comparison is impossible. What we do know is Gemini produces 17% fewer output tokens than its predecessor, which cuts inference time structurally. Gemini 3.6 Flash takes this test because a Flash tier model built for production latency beats a model with a documented 252-second wait and launch period rate limit errors. Running score: Kimi K3 0, Gemini 3.6 Flash 2, 1 tied. The latency story depends on what you're building. K3's 252-second wait comes from always-on max reasoning, which is a feature if you're running overnight batch jobs or deep research pipelines where you want the model thinking hard. For a chatbot or real-time tool, it's a deal breaker. Same model, totally different outcome depending on your use case. Test 4 code generation. Whether you're shipping features, fixing bugs, or running an AI coding agent across a large repo, you need the model to write code that actually works. Benchmark numbers matter here because bad code in production costs real time and money. Gemini 3.6 Flash has 3 published coding scores: SWE Bench Pro at 58.7%, Deep SWE at 49%, and MLE Bench at 63.9%. Kimi K3 has no published figures on any of those benchmarks. Moonshot describes K3 as built for long horizon agentic coding, but that's vendor reported, and one hands-on blog review found Gemini produced code with incorrect element placement on a real website task. This test is a tie. Too close to call. Gemini has the numbers, but K3's vendor claims about deep agentic coding haven't been disproven. And one hands-on review caught Gemini making real mistakes. Score stays at Kimi K3 0, Gemini 3.6 Flash 2, 2 tied. The code generation gap depends on what kind of coding you're doing. Gemini's published benchmarks are solid, but that blog review showed it missing design requirements on a practical task. K3 is built for long horizon work across large repos with parallel sub-agents, which is a different job entirely, and benchmark scores don't always predict real-world output. Where Kimi K3 wins. If you're hitting the same large context repeatedly, K3's cache head pricing drops input cost to 30 cents per million tokens, which actually undercuts Gemini K3, also runs a 1,048,576 token context window with no long context surcharge. And for deep agentic work, K3 Swarm Max coordinates hundreds of parallel sub-agents across thousands of tool call steps with no published Gemini equivalent, where Gemini 3.6 Flash wins. It costs half as much at list price on both input and output, with no mandatory reasoning surcharge stacked on top. It has 3 independently reported coding benchmark scores you can actually verify, and it's built for production latency with 17% fewer output tokens than its predecessor and no documented rate limit issues at launch. The decision rule: if you need low latency, verified benchmark scores, and the cheapest list price today, go with Gemini 3.6 Flash. If you're running repeated large context workloads or need deep multi-agent orchestration at scale, Kimi K3's cache economics and 1 million token window start to make sense. K3's reasoning quality claims are still unverified, so factor that risk in before you commit.